Everyone to Birmingham Elixir. We have Oliver, and Oliver. I just put these together. So we've got Oliver, Josh Adams, and myself, Kevin Brown, hosting tonight. We're going to talk about testing with Jeffrey. He's written the book on testing, literally written a book, but I'll let him plug his own stuff. We're really excited to have him tonight. And at the end, we'll have a little Q&A time, so stick around for that. He'll have his presentation, and then we'll have some Q&A afterwards. And then, as Oliver mentioned, we're giving away a ticket to Codebeam. So if you use the link in the chat window, you can sign up, and we'll pick a random winner from that. So that's all for me, and I'll turn it over to Jeff.
Awesome. Let me get the screen share going, and we'll start talking. Okay. Can you all see my screen? All right. Excellent. I'm going to ask real fast before I kick off. Somebody out there has a decent amount of background noise. I'd ask maybe that folks just mute their mics, and then I'm as I talk, I will actually welcome questions. More than happy to stop and pause. But if it looks like, or if I evaluate or judge that it's going to be something that will actually kind of derail us time-wise, or derail the the momentum of the talk, then I'll just simply ask you to yes, that's that's a great question. Can you hold on to that to the end? And we will definitely have time. So I'll give you a little introduction. We'll go through the structure, what the talk's going to be, and then we'll dive into the meat and the potatoes. So hi, I am Jeffrey Matthias. I am a software engineer or developer or whatever you want to call it. I'm actually going to lead with the ways to get in touch with me, and then we'll talk about why you should care. So first off, if you have any questions, if you want to follow up with anything about this, and I will send out, we will get links, anything. Sorry, I actually gave this disclaimer before most of you showed up. This is my first reveal.js presentation, my first time using it to do a presentation. I discovered that it purported to have this really nice feature where you could get PDFs from it, and it's trash. So not the reveal.js is not trash, but it's not good. It's not cool that they're relying on that in the long run. So as a result, I was intending to hand out my presentation to anybody who wanted it for information, although the actual slides are fairly sparse. I instead will just begin to make sure that everything that comes up as a link or any sort of information on this, we will distribute those afterwards. So with that, anytime anybody wants to hit me up at jeffreycommunity.com, please don't hesitate. Or on Twitter, I'm Idle Hands. My DMs are open. You're also welcome to follow me, but I will give you a warning that I do not work very hard to separate things that are Elixir related from my political opinions, etc. And so it will not hurt my feelings if you DM me to just get in touch and don't follow me. That's totally valid. You don't have to suffer through my opinions with me. So why should you care? As Kevin alluded, I'm one of the two authors on testing Elixir from Prague. It is currently in beta, and I'm going to say this in front of all of you so you can hold me to it. We are trying to have it in the final tech review by the end of this month. Which means that it'll actually be available in paper within the next few months. And my co-author is if people aren't familiar with Andrea, is Andrea Leopardi. He is What You Hide on Twitter and in GitHub, and he is a core team member. We've worked together now for a couple of years, 3, I think. Across a couple of different companies, and we figured out a while back that we got along pretty well. And I was complaining there wasn't a very good a conversation starter for how to start testing in Elixir, and just a place to get people on the same page before they go off and kind of start figuring out their own stuff. And asked him if he'd be interested in trying to do that with me, and then we proposed it, and Prague took us on. So like I said, that's coming out. You can actually get to it now. And the biggest thing about it, though, and this is why it's relevant to all of you tonight, is even if you don't feel like giving us your money, and that's totally fine, the sample code is available on the website. That's one of those links I'll send out. And in fact, I will be even referencing some code that's in there so that you, so just another way for you to kind of get value out of this, hopefully. So I work at a company called Community, and I like them well enough that I'm willing to wear their logo on my forehead at the moment. So real rough overview, we basically make it so that anybody with a fan following can stay in touch with their fan base via text message. And the reason that matters is because we don't have an algorithm. We don't filter things that go out. So it's actually real conversations back and forth. The other reason I care is because I was the third backend engineer at the company, employee number 7. And so I've got a lot of time and energy over the last couple of years into this place. Again, the links at the bottom. We are hiring right now. We're looking for mid, senior, and principal engineers. I'm more than happy to field questions with the contact information I give out later. If people want to, you know, and the link that this is for right here will also be part of that stuff. But I'm more interested if you, like, I'm more than happy to have conversations if people want to learn more about it before they just go blindly apply. And you gotta love that is. Let me get that fixed real fast. Sorry. Okay. There. All right. So this actual talk itself is going to be structured in 3 parts. It's going to be things to think about when writing tests. And so we're not actually going to be diving very heavily into Elixir code specifically here. And I am going to, and it's because I'm mostly operating with the assumption that a lot of you have XUnit experience already, and that consists, or that actually represents about 90% of the tooling that we typically use inside of testing. What I am going to do then is jump to one of the other tools that we typically bring in. It's called Mox. It's it's a library that's intended specifically to create test doubles. And then after I get through that, and so we've gotten, when I say we, it's Andrea Leopardi, another guy named Joe Merriweather Webb, and I have kind of over the last few years been working together and kind of put together some patterns that have worked pretty well for us and kind of take away some of the boilerplate pain of working with Mox. So I'll talk about how we do get through that stuff. So I'll give a presentation on that, and then after that we'll round up with a Q&A. Oh, I forgot I have really pretty animated slides that I just totally ignored. Cool. So the first thing I want to talk about, and when we, so when I said talk about things that we talk about, things to think about when we're testing, the majority of my career has been working in code bases that a lot of people are getting into, whether it's because somebody's jumping over and working in and having to do some work in there, or just because it's a long-lived code base, and so there's a lot of people who've worked it over time. But what I've discovered is that because when you get, or actually the person who actually gets into applications I cause and causes the most trouble tends to be me a year after I wrote something, when I've completely forgotten what I did or why I did a thing. And so what I'm going to be talking about today is a lot of stuff that you can do to improve the quality of your tests, just to be thinking about in the background while you're writing your tests, so that you can create a test suite that actually helps prevent regressions and sometimes even serves as documentation, right? So it's there as a help for yourself rolling forward. So one of the first things I want to talk about is every function that we deal with typically has either a return value or a side effect or both. And so when we're looking at return values, basically we're talking about our test process is calling the code under test, and that's what I'm going to call anything that we're testing itself, right? So it's calling that, and the return value is just whatever comes right back in response, right? Where you're very used to that. And then side effects, it's the test process is calling the code under test, and as a result of that call to the code under test, the code under test is then actually sending a call out somewhere else. And that call might either be either a command or a query, basically asking for information or telling something else to create a side effect. Sorry, my speaker notes are misbehaving right now. So what it comes down to is that we want to draw a box around the code under test. And when we do that, what we're focusing on is you don't want to know how that code is actually implementing the thing. You just care about what's going in, what's coming out. So basically anything that violates the edges of that black box is what you want to focus on, right? So you want to focus on what's going in, what's coming out, and then again, those side effects, right? And that really should be the only focus of your test. And the reason why is that gives you the ability to refactor things inside of that code, like, you know, whatever that API is for that code. It gives you the ability to refactor that stuff it gives you the ability to refactor with safety, basically, without consistently breaking the tests, right? So you know that your tests are still behaving from the outside, which is really what the point of a test, you know, predominantly is to make sure we're maintaining a contract, but it gives you the freedom to play around. And in fact, one of my favorite things to do is to go play in well-tested code where I know that if my tests are passing, my code is working. And that's one of the places where we get to go explore, find new ways to do stuff, because no matter what, we know that we're going to end up in a place where we have our code is still working, and that's the place where I tend to find the most discoveries, or be able to make you know, find new patterns, or even just play around. Because frankly, one of the reasons I work in Elixir is that after 5 years of it, I still enjoy it. I still like finding things. I still like playing around with it. So one of the other things that tends to happen is we'll have certain conditions in which, you know, something should be successful, and certain conditions in which it should fail. And sometimes that means that we're sticking data in the database. And in fact, probably the easiest one for me to look at is if we were trying to write a query and it's only supposed to find data within a certain, within a certain time range. What you want to do, and I'm going to throw credit out real fast to a guy named Moxley Stratton for giving me the term boundary testing. I always called it limit testing, but I like boundary a lot more. What you want to do when you're doing that is you want your test data, you want a fail case to actually push right up against that. I'm very used to seeing people just plunk something in the middle there, and especially in the context of like a database query, they plug something in the middle of it that they go and grab it, their test passed, and they move on. And the problem is that if part of your business logic is dependent on that query being actually hitting a very specific slice. And again, this doesn't just apply to dates in a database or anything like that. It might also apply to if what you're passing in, the input argument is a number. If a number should return a certain value after sorry, I'm going to pause for just a second and kill the chime. Cool. All right. So if your input number actually will change the behavior, then you should be actually driving right up to those boundaries again. So in this case, I visualize, like I think of things, I'm a very visual person. And so I think about a lot of this stuff this way. And so basically what it comes down to is you want your test data to be right up against that edge, right? And so for a bad test, you're gonna be right up against the edge, right to this as far as you can go. And so when I say that, usually with a database, you don't need to go, usually being a second off is sufficient, because we're usually looking at things on the hour, but you can go milliseconds. You need to decide the level of precision, but the idea is if you're even thinking about it, you're likely going to be writing a test that gives the protection, that gives the validation that you need, right? And so then thinking about it this way, if we were trying to select data from just within a time slice, then you want a test item, or sorry, a piece of test data that's then right inside of that boundary. And then because we're talking about a range, you're going to do the same thing there, and then one right outside. And that will, and especially, like, I think one of the places where I have found this to be absolutely one of the most useful, and this is not going to be a surprise since I keep going back to time, is anything that involves time zones, because time zones are actually pretty evil, especially when you're trying to program against them. So what I have found is that if I very explicitly am setting up the test data in my test, and then that gives me a lot of freedom to figure it out, and I have a lot more confidence that to do this. In fact, several jobs back, I came in and I was working for a company that was doing smart parking, and every query was returning data that was just slightly off, and they couldn't figure out why. And that's actually kind of where I first got to this this concept. So the next thing I want to talk about is that I tend to see people, or I see people missing a lot, is there's a few different concepts that basically let us get to a place where we actually are covering all the things. And by that, I mean, if you're bothering to write tests, people, and especially if they look good, people will think that they're safe to do exactly the kind of refactoring I was just talking about. And so it's really problematic. I'd almost rather, and I don't mean this truly, but I'd almost rather not have tests on something when I'm trying to work in somebody else. I'm coming into something I'm not familiar with. I'd almost rather not have tests than have tests that look like they're covering everything. And so we're going to go over a few different ways that we can actually just a few more concepts that we can think about that will help us make sure that we're covering some of those gaps, or that we're not leaving those gaps. And to be on top, to added bonus is, once you do have solid coverage like that, that means you really do have the safety to go refactor. Somebody else can jump into your code, they can be working on it. It serves as better documentation because they can see exactly how it's supposed to be behaving, because it's sitting there written in your test. And there are actually a couple engineers that are in this meeting right now, or at this meetup in the audience, that have worked with me before. But like, I'm actually notorious for going through when I'm doing code reviews, and when I'm reading people's tests, if I'm looking at the code at the same time, if I think there's a line that looks like it's not covered by a test, I'll actually go pull the code, comment out that line, and see if that test still passes. And I don't shame people, because that's not the point. The point is to try and help. The point is to try and help everybody get better at it. But I know that sometimes people are just sitting there going like, wait, you took the time to do what? But it's, again, because I know that for me, when I jump into code that I haven't seen before, or again, my code from a year ago, I'm going to be honest, it's not a year ago. It's like 3 months ago. My memory, and that might even be optimistic. My memory is not that amazing. And I jump between enough contexts. But so it's trying to cover those gaps is nice. And again, if you're going to spend the time writing a test, a lot of this stuff doesn't take much more time, and you've upped your coverage considerably. So one of the first things, and this is, I mentioned that you are, that you can actually go grab the test code, sorry, the sample code from the book. And this is going to be one of the things in there. I actually, at some point, once we get the book out, I will come around this and a few other functions that I have been working with some folks, and we've kind of honed, and for about 3-ish years. This function. So again, we'll turn those into a library. I just honestly, the biggest holdup is naming things is hard. But there is a copy of the actual code that we're looking at here in that sample code. And in fact, I'll try to even find the file name, like the file path to it from the sample code too, so we can get that out. Although I realize that's not part of the information I'll be passing out at the end of this evening. So basically all this does is it's under the hood, it's a list comprehension that's got, it's a large list comprehension with some logic built into it. But all it's looking to do is, and what I discovered is that people tend to, I think one of my biggest pet peeves, but I also understand why people do it, is like I kept coming across more and more people that had, they were doing controller tests, they were generating data, and they were, they were doing a post, and they were getting the response back. And then they were asserting that a couple of the values from their original data were in the response, and because so they'd write 2 or 3 assertions on it and be, and if you're, especially if you're looking at a set of data that maybe has 15 values or even 5 values, there's some limit to where people just get irritated and just like, yeah, that's good enough, I know it's working, we're going to move on. And I understand that, because we don't want to spend a bunch of our time, and on top of that, it actually feels very tightly coupled. There's a few different things that are going on there. By the way, I want to call out as a side note that the other thing that tends to be happening with that, and I'm not looking at you, Phoenix generators generating tests, but I'm pretty sure they're actually guilty of this. The other thing that tends to happen is, remember we were talking about how you want to draw the black box around your code? Well, in a controller test, your black box is typically your application, or at least the code you've written. And so often some of the things on the outside of that are actually your database, for example, right? And so in my experience, people tend to also skip over testing the side effects when they're doing a controller. So if you, especially like, in this case, we're talking about a post. So people will post, they'll assert on the return value and just assume that that's what's in the database. And most of the time that's true. But I personally have actually seen that not go, not go awry, or sorry, go awry, not always pan out. And especially if you're not doing things like asserting that there is an ID that's assigned, you're not even going to catch that that's happened, right? And so so just as again, we're off on that little tangent, you get that ID back with your return values, go hit the database for that ID and pull that back. And then you would do the same assertions against the return value and a second set against the whatever you retrieve from the database. But if you look at this, we've got so this isn't even a macro. This is just a function with a list comprehension underneath, and it just takes an unordered keyword list. But you hand it an expected. It actually defaults to Atom keys, and it's basically, this is designed, every time I kept coming across places where what I really wanted to do was just compare maps, but there'd be like slight differences between them that made it so that I just couldn't do a double equals, right? And so, and again, I think this ties into why I just keep seeing people kind of skipping or doing just some of the assertions on some of the values. But so what I aim to do when I built this, and then and folks helped me tune it, was to make it just as easy, if not easier, to actually just cover all of the values. And so we've got the expected params. And here, because I was talking about this in the context of a controller test, those are going in, those are whatever I generated are probably going to, I typically generate even though technically they get serialized by the test framework, I typically do leave them in the same context or the same form that they would be once they get to the other side. So we got string keys that will just denote that. Then our actual, in this particular case, this is when we're grabbing the thing from the database, like, hey, did all the things that we generated and posted as params actually end up as values in the database? Because it's coming from the database and we're going to be using ecto in this particular case, they're going to be Atom keys. And again, if I actually didn't have a tuple, if I just handed it media from DB instead, it'll actually just default to Atom keys, because, and that just shows my bias. I definitely default to Atom keys unless I need to use string keys. And then the last one is, hey, give me a list of the fields that we actually are trying to compare between these two. There is an additional function call here. You can see fields for, and that actually is another one that it's sitting right in the same file in that sample code. And it basically will take, I think, a map, a struct, an ecto schema. I'm trying to remember if there's anything else, and hand back a key. Just a simple list of atoms for the fields. Minus anything that is the underscore stuff that you see on schemas. And so with that, you can see we're doing that. And then in this particular case, because we're trying to compare what we posted, and this is the place where this is why you can't even just do a converting over to the to the keys, the key type, and then just do a straight comparison, is typically when you're sticking something in a database, you're actually getting an auto-assigned ID, you're getting an auto-assigned inserted at and an updated at, and so you can't do a straight comparison. So in this particular case, so the one other call out I should say, not in this particular case. So the one other call out I would say is that anything that you're actually leaving out in the fields that are being tested, you should actually, you should intend to then go write assertions on those specific fields below. The reason you're leaving them out is because they don't actually hit, the reason you're leaving them out is because they either can't be in the earlier thing, but you need to make sure they're present. In this particular case, I would probably feel safe just saying, asserting that there is an inserted at, asserting that there is an updated at, and we already, by virtue of having used that ID to grab it from the database, that's not going to be in the params, and we already know that it's a valid thing on the media or whatever we pulled from the database itself. So the next thing that I really encourage people to do is there will be often times where we have 4 different things, values that if we pass it in, and this will have to do with that if we pass it in, that the test should behave a certain way, right? And I see people a lot of times they'll put the 4 into a list and then randomly grab one. So every time you run the test suite, you maybe get a different one. I've seen people just be very repetitive in tests. And so what I really want to encourage people to think about doing instead is using Elixir in their tests, and using list comprehensions tend to be my way. Like they are my preferred tool to reach to when I want to do iteration, but this works with enum.each as well. But so outside of your test, you're actually going to do build out a list comprehension, or again, your other enumerable with whatever the different values are that you would want to run that same test for. And then the next catch on that is that you always have to have a different test name, and you have to forgive me, my code is actually running over, and there you go. So you have to have a different test name. I'm assuming you've all seen when you've accidentally copied a test and forgot to change the description above, the X unit yells at you that you've already named, that you're already using that. So here we're just going to use string interpolation to throw that in there. Looking at this sample, I actually probably in retrospect would have dropped those. I or we or whoever probably did this for length actually, because inspect would also return that same format where you've got it looking like an atom. But the idea is that this actually then is going to build out 2 separate tests. Right, and so a lot of times then you can also, because it's Elixir code, you could potentially, if let's say you were working on a schema and it had we use ecto enum a lot, so you could actually grab, as part of your test, you could say, hey, grab all of these, all of the values, and they should all behave, this test should all be successful with them. Or the other thing you can do is actually do tuples and like, hey, if this is the if this is the input, this should be the output, but you recognize that the test itself is the exact same. It's just those 2 different, those 1 or 2 differences. And so the big catch there is you've got to make sure that once you're inside of the test itself, so you're using, you get to use just string interpolation or whatever you want in the test name, and that's the way that you're going to vary those tests. But once you get inside of the test itself, you're actually in a different scope, and you need to use unquote. So I typically will do that right at the very top. I don't like to, especially if something might be repeated, but if nothing else, it's just because I want this pattern to be as clear as possible to somebody who hasn't seen it before. And thinking about people who haven't, who are new to testing or your code, trying to keep them in mind when you're doing stuff it's a nice thing to do. And then after that, the rest of it is just the same test, right? This particular test doesn't have any specific merit to it. We're just running the same thing over and over again, asserting that we're getting a 409 and asserting that apparently that's an invalid, an invalid call. And so this doesn't just need to, this is a pattern that I recommend you use anywhere where you start feeling your tests are getting repetitive, or you realize you're not exactly giving yourself full coverage because you're getting annoyed that you're actually getting repetitive. This is a way to dry up your testing. And the nice thing about it is that when it fails, because you have a clear test name to it, you're not going to be wondering which of the values, because you're actually placing, and I guess that's really the thing I really want to emphasize, is not only do you need a different test, you should really be using that test name to identify the value that got passed in, so it's really easy to interpret a test failure and know where to go from there. So the next one is, there are plenty of situations in which you write good test coverage, you got everything covered, but you actually, like when the test fails itself, you have no idea what's going on from the output from X unit. You've got to go dig into the file, and sometimes you even have to read into what's happening. There is no time where you're going to have more context about what your test is doing and why it cares than right when you are writing it the first time. And so what you should be doing, and this is possibly easier for me. I test drive 95, if not higher % of what I do. Like when I'm actually getting to code, not just designing architecture or sitting in meetings. But so I test drive just about everything. And so one of the things that's really beneficial about that, but you can do it very easily on your own just by failing, like forcing your test to fail, is what does the output look like? Can I understand this? So in this particular case, datetime compare is very useful for taking two things. There are other ways to do it too, where you can convert it into a Unix timestamp and do a greater than or whatever it is. But this works well. It's robust. But the one catch about it is that the return from datetime compare is bloody unintelligible, right? Like, was the first one, I'm sure that stands for less than, but I don't know if it was the first one that was less than the second one or the other way around. Just like a lot of test frameworks tend to be opinionated on expected or actual first. Like, what is the opinion here? So instead, why don't we just write a custom sentence? Assert always takes an extra optional value that is the sentence itself. And the other thing to remember about this, and we'll touch base on this later as well. Oh, sorry, no. I apologize. We won't touch base on this later. The other thing is that it's actually referring to something that we did earlier. The other thing about this is that when you're writing this, you can actually use string interpolation in the string itself, right? And so for example, when we were looking at the assert values for, if your two values don't match, that assert values for function actually outputs, and it tells you, your expected was this value and your actual was this value. And it has the ability to tell that. So even though you were iterating through a list of things, you're not clueless about where it broke. It stops at that point. It just flunks immediately. So you don't know that everything's, you haven't asserted below that. But it gives you that information right away. So you can start trying to debug and figure out what's going on with your test. And so the only way, and the other place that, so this is really big. If you're ever writing custom helpers like I did with the assert values for, using this should be considered a must. You don't want to, you just want to make sure that people, even though they can always trace back, like, yes, I can trace back through the file, I can see exactly the path, like I've got a really nice error stack trace. But the fact is that if I can just look at my test and understand what's happening, and it took me a whopping 30 seconds to a minute on the other side to just think about how to word it and add that extra string, you have sped things up considerably in the long run. The other one too is I notice a lot of times that if we assert that things are just true, if it fails, that often, like, looking at that, it'd just be like, well, I expect it to be true, and it wasn't, and that is almost always without context. So anytime I'm actually asserting that something is true, first off, when I assert something is true, I'll actually, if it needs to be a true or false Boolean value, I will do that explicitly instead of just skipping and saying assert, because assert will also pass on truthy things. But then on top of that, I almost always make sure that I try to make sure, like I said, I've got coworkers here, I don't want them calling me out. I try really hard to make sure that I've added that custom message to it. The last thing about covering it is using a coverage tool, making sure that that you're actually not leaving gaps in your coverage. So I've been privy to the conversations, I can't remember how many times, about like, well, a test coverage number doesn't mean that your tests are good. And I agree. So let's not focus on the percentage of how much of our code is covered, but instead actually look at the error reports themselves. I recently came across a place where had we been paying a little bit better attention, we had a controller action that had a new pattern, like it had a second function head with a totally different pattern, and we just didn't pick up that it wasn't being tested at all, right? Because because we could see that there was a controller test, and we actually were exercising it pretty heavily there. And so the biggest thing is that, and I recommend Xcoveralls just because it will actually, you don't need to send it to any there. It's actually, it was originally, I think, set up to use it with the Coveralls service, but you do not need that. But it actually does output really fairly readable test files, HTML files, and you just open them up on like locally from your browser, and you'll be able to look through every single file. And what you're going to see is the places where it's hit code and where it hasn't. And so what you're looking for is anytime you have branching logic, there should be a test that is making sure that that logic is behaving correctly, right? Because you've got two places. There's a perfectly good place for somebody to go mess things up and not even know that they've done it, right? And given that I am I am dyslexic, so I can't actually see if I've typoed things. I often have heavy hands, and I'll accidentally put a new character in a line. Won't realize I was in the insert mode, and I'll put a new character on a line without even knowing it, and may not even catch it when when I was going. Like, I can break things. Let's just put it that way. I break things plenty. I'm kind of a klutz. So for my sake, if you're working with me, please do it. So I realize I should have probably had a better transition slide. This actually kind of wraps up the stuff that I really want people to be thinking about. There's more. I could go on. As you all can tell, I can talk. I could go on for a while. And there are a bunch of other things that, in the back of my head, like setup functions. If you're trying to make a setup function work for a bunch of different tests, and they actually have different stuff, don't use a setup function. Just move the setup into the test. It's much easier than to read that test, right? Only pull common stuff up, and only if it's common to the majority of the tests within your describe or however you're organizing your files. And then another one is like, I really, just another throw off, and then we'll move on. Factories. Factories are really useful. I'm actually a big fan of them. But what I really recommend not doing is any sort of implicit building under the hood. So if I'm calling to a factory function, I should be especially if it's like building out test data for a database, any relationship, like any other data, like if it has a nested thing, I should actually be building that in my test and passing that in explicitly. You will find that there's a couple things that go on there. One is that then your tests actually become better documentation about what's happening, and you presumably have another factory function to build out that thing. So you're not talking about a lot of extra work. But two, you're going to find that you're not going to get yourself into dependency problems by using that common factory across your stuff. When you need to go, when something changes, when somebody goes and changes one thing, it's not going to work its way back up and start breaking stuff because you actually have 3 layers of nested implicit builds. So that said, that is my quick shot. Like, if you don't buy my book, at least do these things, right? And you don't really, and again, cannot emphasize enough, the sample code is actually available on Prog, and we'll give out that link. It's just a link to the book. So the next thing, the next part of the talk that we discussed was looking at Mox specifically, which is one of the tools that I've found to be quite useful. It's real fun because everything here it's blue. All the blue writing are links that I realized I was thinking they were going to show up in those PDFs too, and like I really just did not get did not get these done in time to actually have found a better route. But Mox itself was originally written by Jose Valim. And it actually was written as a response to an article that I'm guessing a lot of you have come across, and those of you who haven't really ought to. Oh, look, and even here you can see that he's now announced at the top of the article, Mox. So the whole idea behind this article, and it's one of the drivers behind the philosophy of Mox, is that when you hear people talking about mocking, what they're talking about, they're using it as a verb. They're talking about doing a, doing the process of swapping out a test double. And what he's trying to do is reshape the conversation so that when you say mock, it doesn't mean to do something. It represents a thing, a noun. It's the test double itself. And the reason that matters is because when you start thinking about it that way, you start thinking about, okay, what can qualify this as a test double? And so his article actually drives home that if you're going to substitute something for something else, they actually should have a common contract. And while they're not crazy hardcore enforced in Elixir, Elixir does come with a concept of a contract. They're the behaviors, right? And so one of the first things that Mox has you do, and sorry, let me step back for a second. The reason why I like this, because there are other libraries that can help you do similar stuff or perform similar functions. The reason I like this is because by having to think about a behavior, by having to write callbacks, it is forcing you to do two things. One, it's forcing you to actually think about what your mock is doing and make sure that your mock is working correctly. And the second one is it's just annoying enough that it gets you to think about whether or not you should be using a mock in the first place. And point in case would be that, for example, if you've got a dependency inside your code that is purely functional, so it will always return the same thing over and over again, given the same input, it always returns the same response, and it's well tested, please don't waste your time dealing with any extra boilerplate or building out mechanisms or doing anything else that's gonna replace that functionality, because there's no condition in which it's gonna return an error. You're not gonna ever have to fake it behaving differently, because it's purely functional, it always does return the same stuff. So I'm going to talk real briefly about how the Mox documentation kind of tells you to do all this stuff, and then I'm going to show you a couple ways to cheat. So that I just said I like that friction, but I want to take out a little bit of it so that every time you're rolling out a mock, you're not like, oh, here we go again. So the first thing is actually defining the behavior itself. And so a behavior is basically a module. You'll notice it is just a module, right? We added behavior at the end to kind of keep track of what it is itself, but it has callbacks in it. And those callbacks basically, and this one is really vague, I apologize about the map of the map, but it's basically the same way you're writing type specs when you're writing them on your functions. And so in fact, in this case, you can see that the thing that we were writing the behavior around is actually even has, like, the way I would start is often there's a lot of times where I'm writing something I don't always test in, out, or out, in. It's mostly about wherever I have the most clarity on whatever I'm writing. And so a lot of times I'll write something and then realize later, oh, I've got to actually create a mock for this. But there's a good chance I already have a spec written on it. You'll notice that this is just the same thing as what's on the callback. So, and then after that, since the identity thief module here is saying, hey, I actually meet the contract defined by this behavior, it then declares, hey, I mean, this is actually what it's saying, but with this line, I probably have annotations. Yeah, so I keep forgetting that I built out these lovely highlights in my presentation, which is the reason I used reveal in the first place. So it's got this right here saying, hey, I'm meeting this contract. So now I'm gonna tell you how to avoid doing that. Or sorry, now I'm going to talk about how to actually reduce some of the work. And so what we're looking at here is a solution that works if the only reason you're thinking about building out that behavior is specifically because you're trying to go through the process and build out that test double, that Mox test double. And so what we're looking at is this is the actual thing, not not the behavior, but instead of implementing a second behavior or an additional behavior, we're actually just defining the callback in the module itself. And the reason this can be useful is because for me, at least, one of the biggest challenges I have with behaviors is where do you stick the file? Most of the times we just like, and I honestly think that has been a lot of like that I think that is the biggest resistance point I have seen to people using Mox itself is now all of a sudden, every time they want to go, they want to create a test double for one of their modules, they have to go figure out where to stick the behavior. I was doing it in the original above it, and Andrea came along and said, "I see why you're doing this. What about this?" And to which I said, "Can you do that?" And he said, "I don't know. I helped make the language." And so then I was like, "Okay, this is your fault then." So if this is bad advice, let's just blame him, is what I'm getting at. But no, we've been doing this for a few years now, and really but this only works if the only thing you're actually trying to that you need the behavior for or those callbacks for is specifically because it is for that mock. So in other words, I am not telling you that you should not use behaviors when it's actually the appropriate thing, please. And so what you can see here is that we've got the callback actually sitting in the thing itself. And so the next question is, okay, what are we doing with all this? And so we've now set up the behavior. The next step is that we need to actually create the mock itself. So Mox, for a long time, and I believe it's actually, they've kind of switched their documentation. For a long time, they actually were telling you like, oh, in your test helper, just run this line. And so what it is, and instead I'm suggesting you find a place for yourself, whether you call it support.mox, whatever it is in your test directory, like, or test path. Open up and create a file that is just dedicated to this, because if you're creating a big enough application, you're going to do a bunch of these things, and it's really nice to just be able to, do the whatever your sloppy search is for your, for your files, type in mocks or doubles, and just have it pop, show up there. You'll notice though that it is a .ex file, not a .exs, and we'll get to that in a second. But for the moment, you'll know what we're doing is mox.defmock is going to create this new, it's going to create a new module, and what it's going to do is actually, so you're going to name it, you're going to hand it first a name for the module, and then the second thing is you're going to hand it the behavior, or in this case, this shouldn't actually say behavior on it, because what we did what I was just advocating you do is actually do it with the identity thief itself. I'm going to save you the trouble of waiting patiently of not having to wait patiently while I go fix my slide. But let's just pretend for the moment that you never saw this part here, right? And so what it does under the hood is it goes and looks to find the callbacks, and it says, okay, it registers, it accepts that those are the callbacks that module that it's creating. In this case, the identity thief double can have functions called for those, and then we'll get into what that looks like in just a bit. There is one other thing, is you can actually hand a double, one of your mocks. Now you see why I keep saying double. You can hand your double, you can actually give it more than one behavior by handing it a list. In my experience, if you've got something that's implementing more than one behavior, you may actually have written overly complicated code. I tend not to need to do this. It tends to be that, no, I just need one behavior. I don't, but that said, we all have, sometimes we are able to find some really dynamic solutions to things, and but to do so, we have to actually have something, meet a couple different contracts. To me, that typically tends to be what I call a test smell, where your test setup is actually revealing something that that you might want to focus on or pay attention to in your code itself. And in fact, in my speaker notes, I even said, ask yourself why you did this, but I think I've toned down my internal rhetoric since I first talked about this stuff. So the last thing is, before we actually just look at how you use Mox, is to run through and just, you're going to have to make a couple additions for your Elixir pass, basically. So what it's going to come down to is that in the test environment, because it was oh, my brain just stopped working for a second. Because it was a compiled file and not a dynamic file, so it's the .ex, not the .exs, it's not going to be picked up. Otherwise, you're going to actually just need to add it into your Elixir pass for your test. You may not have them set up in your project, but this is the sample on that code on what that looks like. And I think what I'll end up doing in retrospect is I'll probably just go through this in full screen mode and just do screenshots of every page and then put those together as a PDF for folks as a follow-up. All right. So let's actually see what it looks like when it's in the test itself. All right. So the first thing we're going to notice is that our sorry, there it is. So the first thing we're going to notice is that we need to actually pull Mox in. You can import or require. We use this enough that we recognize the functions so that if we see them, we just know what we're looking at. In this case, we would be looking at expect. And then another one is stub, and there's at least one more. But again, so we tend to import them. It's up to you if you want to do mox.expect or pull them in with an import. So what we're doing here is we have expect. It's then naming the double. So this is the same thing that we just defined in our doubles.ex file, right? And then it's saying, hey, this is the function that we're going to expect is going to be called. Now, the next part is that to do that, we now have to give that function some behavior. And so we don't need to focus too specifically on what this is, but you're going to pass it an anonymous function or a function reference. It's usually an anonymous function, but I'll get back to a use case for the function reference in just a minute, or in a couple slides. But so this is a place where you can start making assertions. So not only is this effectively going to expect that this function got called on your double, but you can actually get more explicit and be like, oh, well, I'm expecting not only should it be doing this, but this is the data. This is, when we're calling out to this side effect, this is the data that should have been passed. These are those parameters. So you can do those here. Now you can actually pin values, or in your function head, in your parameters, you can use pinned values or explicit values, and it will, and Mox, and Mox will accept that. But the catch is that the error when you do that is basically that, and I'm trying to remember off the top of my head, it's either that it didn't get called or it didn't have a it didn't match the pattern, right? And so there wasn't a function that actually matched the data. And so the problem with that is it broke, but you don't know how it broke. So I typically recommend, instead of trying to pin or do anything, pin or have hard-coded values in the for the parameters for your anonymous function, instead just have open parameters, and it could be 4 or 5. It can be however many parameters you have coming in. Have it and do assertions inside of the test body. And then the last thing you need to do is make sure that function has a return value. So in our case, you can see on line 16, it has it's returning what. This is all made up code, but it's just returning something that's established as this is a known good value. So in this particular case, we can do this, right? And so the last thing to remember is that you actually have to define this before you kick off the code, or you exercise your code under test. And so it's always going to be defined ahead of time. If you do it after the fact, it's already happened. It's already executed that code. And you're already you're gonna have an issue because whatever it wasn't set up. It didn't exist. So your code was trying to call something that wasn't expecting it. The double will not. It'll have that function, but it won't have been defined correctly, and so it'll break basically. Like Mox will know that it was supposed to have that function, but it doesn't know what to do when you're calling it effectively. That's what we're doing with this set with this expect. Now the catch is expect, and then I mentioned the other one is there's another one, stub, and we'll hit on that in a minute. Expect will fail, or needs to fail, I should say, if you get all the way through your test and it never got called. You need to know that that happened, because what you're doing is testing one of those side effects that we talked about earlier when we were drawing our black box. This is, this is when we're using our Mox, that is when we are using our test doubles, is when we're testing side effects. And the whole point is that you can't tell from a return value typically that something went wrong. And so the expect will actually raise it. It has to go out. And so that's actually most useful typically when we're doing a command. So if your side effect is that it's telling something else to happen, then it's very likely that if it didn't happen, your test won't catch it unless you're using an expect. And so the way this is set up right here, it'll return and say it was expected to be called 1 time, but it was called 0 times. There's actually an optional parameter that can sneak in. I want to say it's right after the function name, and it's actually the number of times it should be called. And so if this thing should happen, 3 times, you can put that there, and this same expect definition will work for those separate 3. So the catch is that Mox, there's 2 ways that you can actually tell it you need to verify that this was called, because it doesn't just happen on it implicitly, which is one of the reasons we like Elixir, right? Is that very few things are implicit. And so one is that you can actually tell it at the bottom mox.verify. But what I recommend instead is as soon as you are, and this is a fun thing because I was just going on that tangent a few minutes ago about how you shouldn't have common setup if it's not needed. But this is really, really small. It does not take much time, and it's not going to slow you down, and it doesn't confuse people. In your setup for whatever section of your test you're in, if it's for inside of a describe or whatever else, just use verify on exit as part of your setup, and that way any test you write in that file will have that implicitly happening. Oh, and then I've got actually, this is the error that we were looking at if it doesn't actually get invoked during that file. So let's see. And then, like I said, it's just an issue of a function clause mismatch or whatever, like an undefined function clause, I think, when you do if you actually do pinned values or something like that, and it doesn't match. So the next thing is, how are you actually getting your test double used in the first place, right? And so the answer is dependency injection, but we have got several different ways of doing dependency injection. The one that I recommend in this particular case is using your application environment. And in fact, I kind of failed you here because these days we now actually have compile env, and that's even nicer to use in this particular case. So what we're doing here is in a module attribute, and I should pause for a second. This is actually contrary to, I double checked the Mox documentation recently, and it doesn't really have a recommendation on how you should be doing this. But what it used to do was give you a runtime function that hit the application environment. I have big issues with that. I know that ETS is super fast. I've had lots of people that love to show me benchmarks, but but to me, anytime when we're having to do runtime switching in a production application means that, especially if it was to facilitate testing, I love testing. I love being very thorough on testing. I love making sure that tests are I got a book on them. I love them so much, but they should not. We should try to always. There's no absolutes, but you should do everything you can to minimize the impact of testing on the design and the running, and especially the runtime functioning of your code. And so I highly recommend staying away from doing a runtime function that has to hit that. It has to hit the ETS, the application environment, every single time. And I'll show you a pattern instead how we can get through this. But but we'll get to that in just a minute. but so what we are doing here is just getting it and assigning it to a module attribute. And like I said, even better now is do I think it's at compile. I'm trying to remember now. I just started blanking, but it's one of the newer things. And that just means with that, you just need to make sure that every environment you have that value is defined, but that's okay, right? So when you then go to use the real, go to use it, you're going to do it. It's just going to look like that. So instead of doing the module call, you're just going to call. You're going to do the same function call, but against the against whatever's stored in that module attribute. In this case, during our test environment, it's going to be your mock, your test double, and during production, it's going to be the actual real module. So one other thing one other reason, just real fast, if there are any fans of XREF out there, one of the reasons this pattern is nice too is because by eliminating that runtime function where we can actually, where it has to go hit ETS, this actually plays better with XREF, so that by introducing Mox, you're not actually breaking your ability to use a tool that some people are power users of, and I kind of use sometimes when I want to get really, really great squiggly drawings of my dependencies. And so, oh yeah, so this actually just was to show you the pattern I don't recommend you using, which is that runtime function. I should probably not include slides on things I don't think you should do. Let's just move on. And so I'll get back to a minute. In just a minute, we'll get to how, like, the thing that we do that allows us to actually do this at compile time, and why, without avoiding it. But one of the things that I want to talk about first, because it's useful for that combination, it plays into it, is stub. And so stub works the same way as expect. It's got the same breakdown where it's formed just like when you're defining an expect, with the exception if it says stub. The catch is that verify won't do anything if this never gets called. You can never call a stub and it won't matter. And this is something we typically, if you're going to use them, then they should be in a place where you're doing what we call a query. So your side effect is asking for information from somewhere else, but and it's getting it back, but it's not implicitly important to your system that it gets it. So if, for example, you ended up finding that data elsewhere, it doesn't mean your function could still run correctly. So if you went and refactored it and you got that data differently, your function could still run. It's not, and so you eventually we're going to want to go back and clean up the stub. I tend to, these days, I found myself using expect just more often, because that way I at least know I need, if I've changed the implementation of how it's getting that, handling that query out, I at least know I need to go clean up the Mox code that I had sitting in my test. So now that we've got stub, we're gonna look at what we call the pass-through. This is the reason why we can avoid doing runtime switching. So what we're doing here is, instead, in our test, let's say we're writing an integration test and we actually wanted, and that's the reason why the runtime switching exists in the first place, is because sometimes you want to be, for like an isolated test, a unit test where you've isolated just a section of your code, you've got, you need to send back a bad value so that you can make sure your error paths are working. But with, but there are often times where you need the real module in a test. Controller tests for us are one of the ways that we do integrations. So a lot of our controller tests, what we'll do is this. I mentioned earlier that you could pass a function reference instead of a function or an anonymous function. And so that's what we're doing here. What we're saying is, hey, look, we know that we have slipped this test double into our application. It's going to be there. We're making the choice to have this razor thin shim sitting there in the situation where we actually want things to perform like they would in production. That shim wouldn't be there in production. So we acknowledge that now our tests are actually testing a slightly imperfect copy of what's going on in production. But the trade-off is that we were able to get rid of that runtime function. So all we're doing here is we've got the safe double. We're passing it the function that we're trying to create the definition for our stub here. And this is a place where I would potentially use stub, because we are actually just focused on letting our system actually operate it normally. But so we're just passing a reference to the existing function, and it will just work. So we have that razor thin shim, but the trade-off is now in production, we are not hitting ETS every time we need this module. So now Mox actually has a really nice function built into it. This showed up a little later, and possibly after, in fact, for sure, after I gotten really addicted to sticking. And by the way, we're pretty close to the time too. I don't know if Kevin, if I just saw your video kick in, we're pretty close to the end. Yeah. So so stub width, you can hand it the double, and you can hand it the original module, and it'll run through and actually do what I just called the pass through for every single one of them. The only catch is it doesn't work the way I recommended if you're putting your callbacks in the original. It only works if you're actually operating with, if you're actually using behaviors. So there's one other thing I really dig. It's for a long time, Mox didn't have the ability to say this should never be called, but sometimes you actually want to make sure a side effect doesn't happen. I came up with this and actually kind of like it because it tends to be a little bit more expensive. You can do a stub, and then if that thing got called, you'll notice that we're actually just got an underscore on the parameters, but it just does a flunk and gives a useful message. Instead of it getting called, you even can potentially, you know, if that parameter information is useful, you can even throw that into your sentence. I am going to just jump through some other stuff real fast. There's a way to set Mox from context. I recommend doing that as well. That Mox is kind of like Ecto Sandbox, where you need to tell it like, hey, you should be focused on only behaving correctly for this PID, or you're globally available. Set Mox from context just looks on whether or not async true is set to true or false. I recommend just using that as your default, and you probably don't need to tune it otherwise. And then this is the last kind of bonus, and this is one of the things I love about Mox, is that we actually have the ability, it's one of the ways that we can actually test or figure out async testing. And so in this particular case, a lot of times what happens is you want to know, or you need to know that something, there'll be a lot of times where I've got something asynchronously happening, and my test needs to actually, I need a way to know that happened before I can even move on or finish my test. So in this particular case, I typically will do, you're going to end up getting a PID, getting the PID of the test. So it's got to be outside of the stub definition. Inside of your definition, you're actually going to send the test whatever piece of information that you have. And depending on what's going on, then the other thing is that you either do, and I failed to include it here, but you're going to have either a good return value, or you're going to maybe even just call out to the real thing. But you know that whatever the real thing is happens so fast. But that way your test actually can get that. I have another coworker that actually, instead of using these things, will create refs outside of it and use those to pass. And either one's fine. Just use clear variable names when you do it, and you should be in good shape. And so just going to hit a wrap up on those points, and then we'll jump to Q&A. So just about that, running again, the way my power tips on using Mox is cheat if you can, and just put the callbacks into the behavior as long as you're willing to break stubs with. In my experience, I don't think I've ever had more than 2 different functions that I've ever actually really needed to write define for stubs. I'd rather write those 2 lines and be able to just keep not having to do keep having to write those behaviors. Skip the test helper and instead give yourself an explicit path. Ours was the doubles.ex, and you just need to make sure that you add it into your mix.ex and your Elixir RCs. Avoid pinning things in your function heads. Instead, do assertions inside of your definitions. This says keep your stubs dumb. I guess I didn't touch on that point, but stubs, what you want to avoid doing in all of these things is lots of complex logic there. You're really just trying to fake whatever's going on unless you're doing the pass through. You're really just trying to fake things. So all you need to really do is focus on assertions and a return value. The compile time stuff, I harped on that pretty well. We've got pass through as well. stub width, if you are using that. The stub and flunk, I like the output personally more than saying that it should be explicitly called 0 times. Set Mox from context should be your go-to, unless you come up with a really weird situation where you are working in, asynchronous is false, but you want it to be true for that test or something. No, just do it. Just use set Mox from context. And then if you ever, I kind of rushed through the async thing. You'll have my contact information. You're all welcome to hit me up individually if you want to follow up on what I was talking about there or get an example from it. That is what it looks like when I smash 2 talks together. And we're at the place now. I don't know timing wise. I'll leave it up to you if we've got time for questions, or if we want to, if you've got more stuff on your agenda to go with. I've got time either way.
Yeah, let's take about 10 minutes for questions. If we start to run over, we can put a pause on it, but let's do 10 minutes for questions, and then we'll announce the winner of tickets.
I have a quick one off the bat about behaviors.
Yeah.
You mentioned somewhere in there about where you define them. I think I've always defined them in a separate file that was like its own module that was like module name that I'm replicating that behavior. But you said something about like just defining it above where you use it. Can you expand on that?
Yeah, if you've got a pattern, stick with it. And especially if you're using behaviors for a reason besides test doubles, then I think you should absolutely be defining your behavior in a different place. The catch is,
let's say I don't have a pattern currently.
Okay, cool.
In the past.
So yeah, totally. So it really comes down to why you want the behavior. If you just want it to be able to create a test double for that file, and that is the only reason, then the other thing you can do is literally in the same file, you have def module, bob.behavior, you've got your callbacks, and then end, and then right after that, def module, bob, as opposed to bob.behavior. And so they're sitting in the same file. That way it's easy to reference. Because the one thing I always strive for is like, can I understand and get the scope of what I'm trying to deal with, or can I understand what I'm looking at without jumping between files? And ideally that's because we don't have really long files. At that point, you've got different problems, right? But if I have to jump around to understand what code's doing, I won't say I'm grumpy, but especially if I don't think behaviors are something that I'm trying to remember. No, it depends on the editor you're using. You may be able to just be able to control click through, but yeah. So that's what it comes down to is literally defining 2 different modules in the same file, separate of each other, and you can get away with it.
Cool. Thanks.
Yeah. By the way, my feelings will not be hurt if people don't have questions. I know I just spoke for an hour straight, so I can understand if people are just processing.
I have a kind of question with the case. Like recently, I was working on a project where, based on different environments, like on staging and on testing environment, I want to use some kind of mocked version of a module, and in production, the different one. And at the same time, I want to write tests. And also for tests, I want to mock that module with the behavior. Do you like what I did? Actually, I end up with 3 modules: one for my test cases, one for production, and the other one for those staging and test environments. And I was thinking that that's kind of weird for test cases and for testing environments. That should be like the same module, either implemented by me or by Mox. Like, did you have that kind of experience, or any suggestions?
I need to make sure I understand what you're asking first. It sounds to me like what you're saying is that you instead of using something like Mox, you ended up actually creating your own modules for each of those things, and that's that's a situation where ideally if you can, ideally you're in a situation where it's either the test environment or everything else, right? In the test environment, I'm obviously advocating Mox, but you don't need to use that. Writing your own module for that is great. So the question what I'm hearing is, you said it sounded like you had something that was behaving slightly different for staging versus production as well. And so that would be a smell, but not necessarily a problem, right? Because it depends on what the differences are. Sometimes there are things that, like, ideally staging does replicate production as closely as possible. But I think everybody who's worked for more than a year or two has come across a situation, and possibly even less than that, right? Like, has come across situations where, like, well, this, X is just not going to be available. And so when we're running in staging, we're just going to have to deal with this. So like I said, it's a potential smell, but smells don't always result, or aren't always a point to a problem. That's why we call them smells. They kind of let us know that there may be a thing. So I wouldn't be too stressed out about it. If there's a valid reason, like I said, of everything you explained to me, it's more that you have got more than just test and everything else. But if there's a valid reason for that, then I wouldn't be too stressed out about it. And then the other one is, you've now seen a potential alternative as far as if you don't feel like, the reason I like Mox is because on the fly, you can see what, like, in your test itself. I was just talking about how I don't like to jump between files if I don't have to. The behavior of your double is actually explained right in the test file itself, so you can see in the test itself what's happening there. But I also have in the past, definitely, and especially before Mox was around, written my own test doubles, and there's nothing wrong with that pattern.
Oh, thanks.
Yeah, do you feel like did I address your concerns?
Yep, that
Great.
pretty calmed me down. Yeah, I was thinking that it's too bad to have like multiple modules here and there. Yeah.
Sweet. And just for the record, people can ask me also, like, about the book itself, or what it's like writing a book or anything else too, if that's or I don't know, pretty much anything shy of what my kids' names are, I think is fair game. So and I am going to also
any Easter eggs or some kind of funny geeky stuff in that book, or is it not acceptable by some politics, by rules?
No, I think the biggest thing is that the sample code that we're putting out, and especially with the later chapters with testing Phoenix, I think the closest thing you're going to get to an Easter egg is that there's actually a whole lot more sample code than's covered in the book. And it's because I was trying really hard to lay out examples for what it would look like when I write an application. And when you've got these isolated examples in a book, they tend not to be, they're without context a lot of times. You're not seeing them in the thing. And so the catch is that I'm saying this and I'm realizing right now the stuff I'm talking about is not actually in the current beta. So that means it's not actually in the currently available code sample. But when the book's out, I think the biggest thing is that there's actually going to be a running application under the testing Phoenix stuff. It's not huge, it's not fancy, but we tried to cover actually a lot of, I say we, but I did it. I tried to cover a lot of use cases that were, and just lay out like, hey, if you don't know how to do this, like here's a starting place, basically. Like I said, I think that's the closest you're going to find as far as an Easter egg goes. Aside from that, I mean, yeah, no, I mean, anything I try to do that's clever in the writing tends to get edited out because it's not clear. So.
Was it your first book?
Yeah, and like most authors who have labored, and this book has taken, part of it is I got involved with a fast-growing startup shortly after I went under contract for a book. This book has taken significantly longer than we'd intended, but like a lot of authors, I'm going to say, at least for now, I feel like this will probably also be my last book. I'd rather, I like teaching. I like getting people. I like helping people understand things. But this format is rough for me. Yeah. Sweet.